Hi, welcome to the Olympiad geometry. Let's continue our study on Circumcenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Let's see the problem. ABCD is a trapezoid. AD is in parallel with BC. E is any point on AB. O1, O2 are circumcenter of triangle AED and triangle BEC respectively. Prove that distance between O1 and O2 is a constant and O1, O2 equals to DC divided by 2 sine angle B. So this problem, if we don't have the second part, we want to just prove that O1 and O2 is a constant. It's extremely difficult, right? So O1, O2 is a constant. Constant for what? For the position of E, right? Because E is any point on AB. So if we don't have the second part, this is an IMO level problem. But we have that O1, O2 equals to DC divided by 2 sine angle B, which actually give us a hint, a direction to solve the problem. Right, the first thing that we look at is O1, O2 equals to DC divided by 2 sine angle B. We want to prove this. And this should remind us that in a circle, let's assume that in a circle we have BC as a chord, and we know the circular angle A, right, reference to the chord BC. So we already know angle A, we know the length of BC. What's the radius of this circle? We can calculate it by BC divided by 2, right? That's half of it, and divided by sine angle A, which equals to the radius of this circle. Just look at this one and this one. They're in the same form, which means we're looking for a circle that DC is a chord, and this chord has a circular angle as angle B. And we want to prove that the radius of this circle is same to the distance of O1, O2. Okay, so now the question is that how can we associate DC to angle B? It's kind of obvious for this one here. We can just extend AD and we do a parallel line of AB through point C. We call this point as E. Because AD is in parallel with BC, and we did CE in parallel with AB, so we know that ABCE is a parallelogram, which means angle B equals to angle E, which means sine angle B equals to sine angle E. And if we think about the circumcircle of triangle CDE, right, the radius of that circumcircle would be DC divided by 2 sine angle E, which is 2 sine angle B, right? So let's just find the circumcenter of the triangle DCE first. So we can do a bisector perpendicular line here, and then we do another bisector perpendicular line here. We find this point. Let's call it O3. O3 is a circumcenter of triangle DCE. So basically, we want to prove that O3C equals to O1, O2. Right? We want to prove O3C equals to O1, O2. Because O3C, that's DC divided by 2 sine angle B. Okay, now we extend this perpendicular bisector of segment DE, right? We also consider how can we get the O2, that we did the bisector perpendicular line of segment BC. So, right, and let's call this point as F, and this point as G. And how can we get O1? We do the bisector perpendicular line of segment AD. So let's call this as H, right? And also, we got O1 from bisector perpendicular line of AE. So this is 90 degree. And for O2, we got the bisector perpendicular line of segment EB. Right, this is perpendicular. This is 90 degree. So now we know that GC equals to half of BC, right? And if we give the name of these lines L1, L2, L3, L4, L5, we know that because L5 is a bisector perpendicular line of DE, which means the D to L5 is this distance, right? Let's just mark it. Right, so DI and J. Okay, so DI is half DE and DJ is half AD. So DJ 加上 DI, that's JI, that's the equal distance of HF, right? That's the distance of L3 to L5. And we know that this should be half of AE, which is half of AC, equals to half of AE equals to JI. Right? Equals to HF. Right? JI equals to HF. Okay, now we know that GC equals to HF means FC equals to HG. Okay, similarly, we already know that the distance from L1 to L2, that's half of AB. And the distance, let's just draw a parallel line or perpendicular line of CE through point C, right? That perpendicular line has to be in parallel with this line, right? So this is L6, this is L7. We know that L6 and L7 are in parallel. So this point, let's call it L, right? That's this point, the in parallel line. And from O1, we do the projection from O1 to L2. Let's call it M. Similarly here, we call this point N. Okay, this is N, this is L, this is F, this is C. I hope you can see it clearly. Okay. Now we think about that. Because O3N is the distance from L6 to L7, which is half of CE, right? O3N equals to L6 to L7 equals to half of CE. And half of CE, that is half of AB, which equals to L1 to L2, which equals to O1M. Right, so O1M equals to O3N. And we already know that L6 is in parallel with L1, right? Because CE is in parallel with AB and L6 is perpendicular with CE, L1 is perpendicular with AB. So L6, L7, L1, L3, they are all in parallel. And we know that L3, L4, L5 are all in parallel, which means angle MO1H or MO1, let me put a point here, call it S, okay? And let's call this point P. So from O2, we do a perpendicular, we do the projection for the L3. We call this point as P, and MO2 intersect L3 on point S. Okay, so because O1M is in parallel with O3N, and L3 is in parallel with L5, so we know that angle MO1S equals to angle NO3L, right? NO3L. This angle equals to this angle. Because this is in parallel with one, this line is in parallel with this line. Right? So we know that in the right triangle O1MS and the right triangle O3NL, we already know they are similar because this angle equals to this angle. And we already know that O3N equals to O1M, which means triangle O1MS is congruent to the triangle O3NL. Right? O1MS is congruent to O3NL, which means MS equals to NL. Okay, and in triangle SPO2 and triangle LFC, we know that CF is perpendicular with L5 and O2P is perpendicular with L3. L3 is in parallel with L5, so CF is in parallel with O2P, and we already know that O2P equals to HG equals to CF, right? CF equals to O2P equals to HG. That's what we already know. And we know that L7 is in parallel with L2, so angle SO2P equals to angle LCF. And also triangle SPO2, and the triangle LFC, they are all right triangle, right? So that means we have, from this one, we know these two triangles are similar, and from this one, we know they are actually concurrent. So triangle SPO2 is congruent to triangle LFC. Based on this, we know that SO2 equals to LC. So MS equals to NL, SO2 equals to LC, which means MO2 equals to NC. Right? We already know that MO2 equals to NC. We know that O1M equals to O3N, and we know that angle O1M O2 equals to angle O3NC equals to 90 degrees. We know that triangle O1M O2 is congruent to triangle O3NC. Right. So based on that, we know O1 O2 equals to O3C. And O3C is a radius of circumcircle of triangle DCE, which equals to DC to 2 sine angle B. Okay, so once we have this auxiliary triangle down, everything becomes clear, right? Again, this is a extremely difficult problem if the problem set doesn't ask you to prove this part. But with asking you prove this part, it gives you the direction that we can do this, right? Everything becomes very straightforward, clear. I wouldn't say it's still, I wouldn't say it's it becomes very easy. It's still you need to prove several things, right, step by step. But it's much easier without knowing this. Okay, I hope you like this video. Hope you like this problem. See you in next one. Thank you.